Today we're going to look at graphing quadratic functions. Now, two things you need to know about a quadratic function before you graph it and before you really look at them is what a quadratic function is. This is a function that is described as y equals ax squared plus bx plus c. And the a is not going to be 0, ever. Now, the graph is in the shape of a U, and we call that as a parabola. Now the vertex on this parabola is going to be the highest point, which we'll consider that the maximum, or the lowest point, which we consider that the minimum of the parabola. Now your minimum is going to be down here. It's the lowest point of the parabola, and it opens upward, meaning it goes up just like a U. In this case, your A is always going to be greater than 0. So you'll know you have a minimum if your A is greater than 0. And that's when it's in the form y equals ax squared plus bx plus c. Now your maximum point is going to be right up here. This is the highest point on the parabola, and this is when it is opened downward, meaning it's an upside down U. And at this point, your A is going to be less than 0. And when it's in the form y equals ax squared plus bx plus c. When we are looking at quadratic functions, we like to look at the axis of symmetry. This is the line that divides the parabola in half, and they're into two matching parts. So the equation for finding the axis of symmetry for the graph y equals ax squared plus bx plus c, where a is, remember, never equal to 0, you're going to say x equals the opposite of b divided by 2 times a. It will always be this. It will be a horizontal line. That's why we have x equals. So over here in this graph, you will notice that this is the axis of symmetry. It goes straight down the middle of the quadratic function, and right here is the vertex for this function. Now when you're given an equation, y equals x squared minus 4x plus 5, and I want to find the axis of symmetry. Now, in the form y equals ax plus bx, y equals ax squared plus bx plus c, your a in this part is 1, your b is this negative 4, since it's minus 4, and your c is the 5. Now if we take our equation, x equals the opposite of b divided by 2 times the a value, your b is negative 4. So the opposite of negative 4 is 4. Then you do 2 times your a, which was 1. So 2 times 1 is 2. Now you do 4 divided by 2 to simplify, and you get 2. So my axis of symmetry's equation is going to be x equals 2. Now, what if I want to find the coordinates of my vertex? The first thing you need to do is find the axis of symmetry, take this x value, and plug it in for your x in your equation. So if I gave you this equation, I do y equals x squared minus 4x plus 5. I plug in 2 where I see my x values, so I get y equals 2 squared minus 4 times 2 plus 5. Do order of operations, exponents, so 2 squared is 4, then multiplication, so 4 times 2 is 8. Now I add and subtract left to right. So I do 4 minus 8, which is negative 4, plus 5 gives me 1. So now I take this value and my x value from up here, and to get my vertex point, which is 2, 1. Now to determine if my vertex is going to be a maximum or minimum, I'm going to come up here to my equation, and notice my a value we said was 1. So that's going to be greater than 0. So my vertex is going to be a minimum instead. and not a maximum. When graphing, you need to first find your axis of symmetry, which we did in the previous slide. We use that along with our vertex to start graphing our function. So this is the same equation as previous, y equals x squared minus 4x plus 5. I got my axis of symmetry as x equals 2, and my vertex as 2, 1. So I go over here, I plot my vertex, and I'm going to draw my axis of symmetry. Now, the next thing we need to do is find another point, and we're going to pick points that are symmetrical with the axis of symmetry, meaning it's on this side and on this side. So the first one I'm going to do is x equals 3, because right here would be where x equals 3, and find out where it is on my graph. So I plug in 3 for my x, so I get 3 squared minus 4 times 3 plus 5. 3 squared is 9. 4 times 3 is 12. So 9 minus 12 is negative 3. Plus 5 is going to give me 2. So my point's going to be 3, 2. So I go over here to 3 and up 2. Now to get the point on the other side of the axis of symmetry, they're going to be even, in line with each other. For this point, from my vertex, I went over 1 and up 1. So from this point, instead of going right, this time I'm going to go left 1. So I go over left 1 and up 1 to get the point that is symmetrical with the point 3, 2. Now I pick another point. I'm going to do 4, which is right over here. Put it in 4x and solve, and I get 5. So I'm going to go over to 4 and up to 5. Now with this one, from my vertex, I went over 2 and up 4. So on this side, instead of going right, I'm going to go left 2 and up 4 to get the point symmetrical with 4, 5. And then draw my parabola. Notice, the parabola is not going to be perfect when you're doing it by hand, and you can't use a ruler since it's a U shape. So that is why you need to make sure you have several points in order to get your parabola shape. Alright, let's start with another one. We have y equals negative x squared plus 2x plus 1. The first thing I need to do is find the axis of symmetry. So, I find that a, since this is a negative x squared, my a value is going to be negative 1. Since this is 2x, my b value is 2. This is minus 1, my c value is negative 1. So, I take my axis of symmetry formula, x equals the opposite of b divided by 2a. The opposite of 2 is negative 2. 2 times a is negative 2. Negative 2 divided by a negative 2 is a positive 1. Remember, when we divide a negative by a negative, we get a positive. So, I'm going to come over here on my graph and draw my axis of symmetry. At 1, I'm going to draw a dotted line all the way down. Now, I've got to find my vertex. I take my axis of symmetry where x equals 1, and I plug it in for my x in my equation. So that would give me y equals the opposite of 1 squared plus 2 times 1 minus 1. Now 1 squared is 1. Then we've got to take the opposite of that, which makes it negative 1. 2 times 1 is 2, and then we have our minus 1. Now when you do negative 1 plus 2, I get 1. Then you take 1 away, and I get 0. So my vertex is going to be at 1, 0. And I have plotted that there. Now, because my a value, right here we said was negative 1, is less than 0, this point is going to be a maximum vertex. So I should know that my parabola is going to be going downward. So I'm going to find other points. I'm going to pick 2. The first x, I'm just going to go over 1. So that would be x is 2. Plug it in. 2 squared is 4. I take the opposite of 4, which is negative 4. 2 times 2 is 4. So, negative 4 plus 4 gives me 0. Then I subtract 1, which gives me 1. So, I go x is 2 and y negative 1 and put my points. Now notice, went over 1 and down 1. So, instead of going right, I'm going to go left this time, over 1 and down 1 to get my symmetrical point on the other side. Now I'm going to pick 3. So I plug 3 in and you get negative 4. So I go over to 3 and go down to negative 4. Now to get it on the other side, instead of going right, I'm going to go left 3. So 1, 2, 3. Wait, 1, 2, 3, yeah. And then I go down, so I'm even with this other point at 4. Now, some helpful hints. Remember, when my A is greater than 0, I'm going to have a parabola that opens upward, and my vertex is going to be a minimum. When I have an A that is less than 1, a negative A value, then my parabola is going to open downward, upside down U, and my vertex will be a maximum. Now my A value is always going to affect the width of my parabola. The smaller the A value, the wider the parabola, more like a straight line versus a U. The bigger the A value, the skinnier my U is. Your C value is where it crosses the Y-intercept.